In this, you just have to figure out the first 5 terms of the sequence. The sequence is given by a sub n equals 3n plus 1 over n plus 5. So that just means for the first term, it would be like 3 times 1 plus 1 over 1 plus 5. Just plug in 1 where you see n. The number of term goes there. And this is 4 over 6, which also equals 2/3. Pause your video now so you can figure out the other 4. The second term give you 7 over 7, or just 1. The third term would give you 10 over 8, which, if you were to divide some things out, would give you 5 over 4, or 1.25. The fourth term would be 13 over 9. And the fifth term would give you 16 over 10, which is 8 over 5. Now, if we were trying to figure out a limit as this approached infinity, well, quite frankly, I don't really know where it's going. 2/3, 1, 1.25, it just keeps getting a little bigger each time. But if we're looking at huge values of it, we could try plugging in huge values of n, but that would get a little messy. Let's figure out an algebraic way instead. So, when you're looking at limits of sequences, if you know the function, which we do, we had it before in the brain starter, then to find the limit of the sequence is basically saying what happens at huge values of x, where does this eventually converge to? It's the same as finding the limit of the function itself as x approaches infinity, which, from other things, we know how to do. So, to find where this sequence eventually converges to, essentially all we're going to do is look at the limit as x approaches infinity of 3n plus 1 over n plus 5. Now, remember with rational functions, we were looking at the highest powered terms on the numerator and denominator. That's 3n and n. And since they have the same degree, that means we're really just looking at the coefficients of it, which means this limit here is 3 over 1, or just 3. So the sequence will just keep getting closer and closer to 3 as the x values increase.